Welcome to lesson 11. We're going to continue working with inverse functions. Okay, so I want to quickly go over the properties of inverse functions. The first one that we noticed was that given a graph of a function f, the graph of its inverse is going to be found by reflecting the graph of f about the line y equals x. So let's take a look at a general situation here. We'll take a look at the function f being the square root function, square root of x. I'll draw that now. And then its inverse is going to be x squared. And if I graph the function x squared, I can see that it will be a reflection about the line y equals x. So I'll draw the line y equals x, and then we'll take a look at the inverse graph, the graph of x squared. So now when I reflect this green curve over the line y equals x, I can clearly see what it's going to look like, right? All of the points on the green curve are going to reflect over to new points, and I'm going to end up with the graph of x squared. So these points here are going to reflect over and down, and this will result in the following. This curve here. And now we have a really nice way to sketch the graph of an inverse function given an original function, as we've done here. The next property that we noticed was that just as how the inputs of our original function become the outputs of our inverse, and vice versa, so the outputs of our original function become the inputs of the inverse, the domain and range also switch. So the domain of our original function, which was of course represented here by this little section of x values, it's going to become the range of the inverse function. And I can diagram this pretty clearly. So the original function f will map some value from x to y. So if this is the function f, we can say that the domain of f are all these x values, and the range of f are all these y values. Well, the inverse function does the inverse. It takes you from a value in this set here, one of these y values, and maps you back to the original x value. That is f inverse. So if we look at the f inverse function here, we see that its domain, all the input values, is this set here, and the outputs, its range, is this set here. So you can see that they just switched places. Okay, and this is something that we can take advantage of as well. It allows us to make quick work of deciding what an inverse function should look like and what its domain and range happen to be. So let's get a little practice here. We've actually already found the inverse function for the first three. So you know what the inverse function is. That will help you. But what you want to do is find the domain and range of your original function, sketch the graph of the original function, and then do the same for the inverse. So try to make that as quick work as possible using the properties that you just saw. Go ahead and try one on your own first. We'll take a look at that one together. Okay, so here's the graph of my function. Remember, it's the square root function with a translation of 3 units to the left. And that means that the domain are going to be all values, x values, from -3 on to positive infinity, and it will include -3. So that's the domain. And the range is going to be all y values starting at 0 and then going on to positive infinity. Now, because we know the relationship between an original function and its inverse, we can actually sketch the graph of the inverse and its domain and range without having to go solve for the inverse. So even though I know that the inverse function is x squared minus 3, I don't need to know that in order to sketch the graph of the inverse and find its domain and range. So let's take a look. First, we're going to sketch the graph of the function, and I know that it's going to be a reflection over the line y equals x. So what I'm going to do is I'm going to sketch the line y equals x here. And I'm going to reflect my curve over that line. So this point here is going to come down to this point here. -3 on the y-axis. And I can just sort of sketch those out like that. And I can see here that this is very clearly going to be x squared minus 3. So a parabola translated down 3 units. I can see its parabolic shape. And I notice that it's only half of the parabola. And the reason it's only half of the parabola is that its domain is the range of our original function. So the domain is going to be from 0 to positive infinity. I can see that really clearly when I look at the sketch of my graph. The first x value that I can plot is when x is 0, and I can go all the way out to positive infinity. And similarly, that means that the range, I can see this by looking at the graph as well, but also noting that the range of my inverse is the domain of my original function. So it will be from negative 3 to infinity, and I can see this really clearly here. The lowest y value I have is negative 3, and I can go all the way up to positive infinity. Like that. All right, go ahead and complete 2, 3, and 4 on your own. Once you've done so, go ahead and press play, and I'll give you 2 more questions that you want to work on. All right, so here are 2 more problems for you to work on. Both 5 and 6 should be completed. Neither of them require a ton of work. You just want to make sure that you're thinking about the relationship between a function and its inverse, and so this will help you do so a little more deeply.